Hi class, so today we are going to be expanding upon what we know about quadratics, and we're actually going to look at some application of it. Okay, so today we're going to be looking at quadratic story problems, at least in one perspective. We'll be adding more as we get later in the trimester. There's a notes with some sample problems that you can print off if you want. You can open this up in Canvas. You don't have to write down all of these words if you want. We're not even going to look at all of them. But I just have that there. That's what we would use in class if it was a normal in-class day and we weren't hybrid and all that stuff. But so those are available to you as well if you want those. But before we even get looking at those samples, when we're sort of looking at these quadratic story problems, I want to take you back and remind you about some information we learned way back when at pretty much the beginning of first trimester. So at the beginning of first trimester, we looked at story problems in general. And so we've talked about some different key things with that. I want to look at some specific information with story problems to tie together. So let's say we're given a story problem that says something like, the length is 4 more than the width. Now, this doesn't have the rest of it in information to write a story problem. I just want to talk about the concept behind how we can define two unknowns. So we talked about regular story problems at the beginning of the year. We added in system story problems that had two unknowns. And now we're sort of piecing that together. We have two unknowns, but we have those key terms that we learned about at the beginning of the year that link them. Okay, so in this situation, we don't know what the length is, and we also don't know what the width is. Okay, but we do know that the length is 4 more than the width. Now, you could define whichever one you want first. My suggestion is always going to be that whichever one comes second when you're reading it is the one that you define to just be whatever variable you want. So since width comes second, I would say that my width equals, you could choose X, you could choose Z. I mean, I'm going to choose W. I think that choosing L for width would be a poor choice. Okay, and then we're just going to go off of our basic key term translations that we learned way back when at the beginning of math. Okay, so it will say the length tells us to put an equal sign for more than. More than tells us to add. Okay, so remember than sort of told us to switch the order, but since it's addition, it doesn't matter which way we write it. I'm going to write it at the end just because that's what we tend to prefer to see. For more than the width. Well, our width is now W. Right? So our width is just W and our length is W plus 4. I defined it by using those key term translations that we learned at the beginning of algebra. So we want to take that type of skill and we want to apply it to a story problem. So we want to find the dimensions. If you don't know what the word dimensions means, that means we want to find the length and the width, okay, of a rectangle with an area of 10 square feet if its length is 8 more feet than 2 times the width. Okay, so this story problem is asking us to find the dimensions, find the length and the width. So we have two unknowns. Okay, but again, unlike a system, we have key terms that show what the length is in relationship to the width. So like I recommended, I think whichever one we read second, whichever one shows up second, we should define first. So I'm going to say that our width is W. Okay, it then asks us to consider the length. So the length, it says, means equals 8 more than, 8 more feet than, right? 8 more than. I'm going to, again, put that at the end. It doesn't matter because it's addition, but that's just what we're used to seeing. 2 times the width. So 2 times says multiplication. And when we're taking 2 times the width, 2 times W, we don't need to write a multiplication symbol in there, right? And if you had me, that was something that we talked about first trimester. Multiplication tends to sort of take care of itself, right? We don't necessarily need to write a symbol all the time. It usually takes care of itself. Okay, so now we have these defined. So now if we go back up here and say, okay, what is this problem asking us to find, or what do we know, I guess? We know that the area of a rectangle is 10 square feet. This is something we hopefully know, but to find the area of a rectangle, right, the formula is area equals length times width. So we just want to substitute in each of these values. Okay, so if I'm multiplying the length and the width to find the area, I have W and I have 2W plus 8 that I need to multiply together. You could, again, write these in either order, but I always think writing the one that's by itself first is easier because that's, again, traditionally how we see the multiplication written. And we're going to set that equal to the area, and the area, it tells us in this problem, is 10. Okay, so if I want to start solving this, I cannot solve this by factoring right now because this does not equal 0. So that's not a choice. Don't think, oh, that's factored. I can just set them both equal to 0. That's not a choice. So we need to get rid of these parentheses to see what type of situation we have. So to get rid of the parentheses, we'll distribute. So W times 2W is 2W squared. That's from our polynomials unit, right? We add those exponents. W plus 8 is 8W equals 10. Now we have a problem that looks like what we've been dealing with. So we want to use those rules we talked about yesterday to decide which way we want to solve this. Okay, and there are various approaches that you could take. You could set it equal to 0 and try and factor. Okay, you could set it equal to 0 and use the quadratic formula. This is currently not in the form to complete the square because A is 2. I think for the majority of us at this point, if A isn't 1, the majority of us are probably going to set it equal to 0 and use the quadratic formula. But if you go another way that is appropriate, that would be totally fine. Okay, so that says A equals 2, B equals 8, and C equals negative 10. And so now we're just going to start solving this with the quadratic formula. Okay, so we're just going to start plugging in. Negative 8 plus or minus the square root of 8 squared minus 4 times A times C all over 2A. Okay, if you're not sure where all those numbers come from, you might need to go back and watch the video over the quadratic formula. Okay, then we're going to put in the info underneath our square root, right? We're going to simplify this stuff underneath here. So whether you use a calculator or whatever, when we put that in, we're going to get the square root of 144. Because now we're just talking about using the quadratic formula, which we should already be comfortable with. Okay, so the square root of 144 is 12. And we're going to calculate then both options from this. So we'll have negative 8 plus 12 over 4 and negative 8 minus 12 over 4. Okay, so up here we'll get 4 over 4, which equals 1. And here we'll get negative 20 over 4, which equals negative 5. Now, we have to make sure we are very clear on what this 1 and negative 5 equals. Right? Normally we'd say the quadratic formula says x equals, but in this quadratic our variable was w. So this is w equals, right? This says w can equal 1 or negative 5. Okay, mathematically speaking, it could be both of them. But this story problem is asking us to find the dimensions. So if I'm talking about a rectangle, could I ever say that this has a side measurement of negative 5? Right, hopefully we're all agreeing no, because we don't talk about distance as a negative number. So while mathematically speaking, negative 5 is an option, for this particular story problem, negative 5 doesn't make sense. It's not reasonable. Okay, it's not a reasonable domain, which we also talked about in first trimester. Okay, so that tells us then that our width has to equal 1. So we know that our width is going to equal 1 foot, right? It tells us that it's feet, but we're not done yet because it wants us to find the length and the width. So to find the length, we then have to take this 1 and plug it back in over here. Okay, which we have also done before. So if we take 2 times 1 plus 8, that gives us 10. So that tells us that our length is going to equal 10 feet. So we have a width of 1 foot and a length of 10 feet. And we could check that because 1 times 10 is 10. So that also matches our area of 10 square feet. So I never said that these problems were going to be short, right? This is definitely a lot of work. But I do want to look at one more here. And we're going to choose one more from the second page. Okay, so we're going to choose this last one down here. And it looks like I changed something on my paper. But we'll see here. Okay, so a rectangle has an area of 188 square feet. What are the dimensions of the rectangle if its width is 5 feet longer than 3 times its length, right? So here's that key phrase we're looking for. So whichever we read second, we want to define first. So our length is just going to be itself. So I'm going to pick L. Okay, you could pick X, you could pick whatever. The width is, so equals, 5 feet longer, so that's addition, than 3 times the length. So 3 times the length is multiplication. So we now want to find the area. So if we do our 2 sides being multiplied together, right? Our length times our width, we want to equal our area of 188. Okay, and then we'll start solving, so we could plug this into the quadratic formula or solve by whatever. So I'm going to distribute. So 3L squared plus 5L equals 188. Again, you have the option to decide how to solve this. A does not equal 1. So I think for a lot of us, right, we're going to go to the quadratic formula. Some of us might be doing the quadratic formula every single time. That's okay. Okay, and we can now plug this into the quadratic formula. So we're going to do negative b plus or minus b squared minus 4 times a times c. That's a negative 188 in there. All over 2 times a. Okay, so again, underneath the square root, we want to check and get that number. Okay, we get 2281 all over 6. Now, our next step at this point would be to check and see if 2281 is a perfect square. So if I take the square root of 2281, I get this big long decimal, and this is not a perfect square. Now, when we were doing these in class and solving with the quadratic formula, we would start prime factoring and simplifying that. But if we get negative 5 plus or minus the square root of 2281, or a simplified version of that radical, does that give us any better idea of what the actual length and width are? And the answer to that is no, right? We're actually ready for a label. And when we are ready for a label is when it is okay to get a decimal approximation. Okay, so if we take the square root of 2281, we get this big long decimal. I'm going to ask you to round to 2 decimal points. Okay, so we'll say negative 5 plus or minus, and then we'll round this. So 47.7, right? I need to bump that up to a 6 because there's a 9 following it. And so here we can do just like what we did before and calculate both options. So negative 5 plus 47.76 over 6. and negative 5 minus 47.76 over 6. So I'm going to use my calculator to help me on that. So negative 5 plus 47.76, make sure you hit equals. So that gives me a 7.13. Negative 5 minus 47.76 equals divided by 6. And that gives me a negative 8.79. Okay, again, what did I solve for? My variable was L. So these are the options for my length. A measurement doesn't make sense when it's negative. So my length is going to equal 7.13 feet. But I'm not done yet. I still need to find my width. So I'm going to plug in that 7.13 up here, right? So I'm going to do 3 times 7.13 plus 5 equals. And so my width is going to equal approximately 26.39 feet. And those are my measurements for my answer.